what's like the whole point behind IP addressing? What's the whole point?
To get to your destination.
Yeah. And how does it, okay, let me put it this way. Let's go for this one. Let's put it this way to make it a bit simpler. So I go, yeah, mm, okay. So I've got, let's say I've got a device here. I've got a device here. I've got a device here. And I've got a device here. And let's say this device is connected to this Cisco switch here. And this one is connected to the Cisco switch here. This one is connected to the Cisco switch here, and this one is connected to the Cisco switch here. And let's say we have, let's get Cisco router. Cisco router. Let's get a good one. Yeah, this one would do. Yeah, oh no, no, it's not clear. Yeah, let's get maybe this one. And we just go um, um, yep. Okay, so we got a Cisco router in the middle here, connecting all these switches together. So we have this switch connecting to this one connecting to this one connecting to this one, and this one connecting to this one. So what I would like is if you can you describe the process of um, if this machine wants to send this packet, so there's a packet, this machine wants to send this packet all the way to this machine over here. Can you describe the processes that it's going to go through to send to this machine over here?
Um, is that the MAC address?
Yep. So so it will send the MAC address of what? So let's say this machine wants to send an information to this one. What would be the first thing that it's going to do?
Um, no, it's IP.
You know, it's IP. So, okay. So it knows it's IP. So once it's like, okay, it finds the information. Let's say this one is 192.168.2.1. Let's say this one is 192.168.1.1. So once it knows its IP, so what will it do?
Um, Send its packet to that other IP.
To the other IP. So it will
Yeah,
just send this packet straight to this IP. So
right.
what would the packet look like? So we'll have a packet here. So here we'll have our source, and here we'll have a destination. So what will be the source IP here? So we go source. So now I want to send a packet from this one to this one. So what
From
will be the
dot
source
two.
IP? So source address is 192.
168.
Yep.
.1.1.
.1.1. Yep. Good. So what about the destination IP? So what will be the destination IP?
192.168.2.1.
192.168.2.1. Yep. Good. So then after that, because there can be layer 3 without going through layer 2, right? So you have
Right.
another field there. So this packet, we have another field there. And this other field in this place will be source layer 2 or source MAC address. So let's say the MAC address of this one is AAA, just to make it simple. MAC address of this one is BBB. So what will be in the source MAC address field? In the source field, what will it put, what will, so this machine is like, oh, I want to,
BBB.
yeah, source, as in the source layer 2. So let's say this one is AAA, where it's coming from, where it's
AA.
going through as the MAC address of BBB. So what will be in the source MAC address there? I said, hey, right? Then what about the destination MAC, destination layer 2 address? So what will be in the destination layer
Um,
2 address?
BBB.
BBB. And then after that, it will have its data at the end, right? So then this one will be this the data that I'm actually sending.
Right.
Yeah, but this is not correct. And there's only one part of it that is not correct. This part right there. This part right there is not correct. So why is it not correct? So you got other parts, right? So this machine wants to send a message to this machine. So the first thing it will do is it will compose a packet. So the packet will be, okay, my address is this. The destination that I want to go to, the layer 3 address is this. Well, my MAC address is this, but it won't send it, it won't put the MAC address of this guy here. Why is that? Is there any reason why it's not going to put the MAC address of this guy here? What do you think, Sean?
You have to have the MAC address for the router.
Yeah, exactly. That's absolutely correct. Because
Does it have to have the MAC address for the router?
yeah, so the router here has to, so that's the first information that you need is that you need the MAC address of this one. So let's say the MAC address of this one is CCC of this port here is CCC. The MAC address of this one is DDD. The MAC address of this one is EEE. The MAC address of this one is, let's say, 111. So what will be in the source MAC here? In the destination MAC here, sorry. Because
Um,
this will not
First
be
would
the
be CCC.
CCC, okay? So, and here's the question that I want to ask is that, so it says CCC. So let's go back to home. Let's select this one. Let's delete this one. So he said CCC.
Right.
So he said he's gonna say, okay, I'm going CCC. Why is it that it's gonna send the destination to CCC? Why?
Because that's um, the for the going to the router.
Let's make it even more interesting. Let's put another device here on this switch. And this device, actually, let's just make this. So let's put another device here and put this device here and call the MAC address of this device 222. So if this machine wants to send a message to this other machine, yeah. So what will be in the this one is 192.168.1.2. So what will be in the source IP address? That this one. So this one is it's so we'll come back to this one. They send a message to this one. But now, if it's sending a message to this other machine on its network, what will be in the source IP address?
192.168.1.1.
Yeah, right. What about the destination? What will be there?
192.168.2.1.
Dot 2.1. It's sending to this one. It's sending to this other device that is sitting next to it.
Oh, next to it?
Yeah. So it's sending to this one now.
192.168.1.2.
Dot 1.2. Yeah. So what about the source layer 2? So what will be in the source layer 2 address? So what do you think, Sean?
Oh, AA.
Yeah, yeah. And the destination, what will be in the
AA.
destination layer 2 address?
222.
222. So can you tell me why this one, when it's sending to this guy here, it's putting 222 here, but why it's sending to this guy here, it's putting CCC here? Why? What's the reason for that?
Because that's this. It's one into the router.
Yeah, but why is it not sending
Instead of
this one?
another.
But why is it not sending this one to the router 2 on layer 2? What's the reason for that?
I'm not really sure.
Yeah. Okay. So that's the whole point of what we want to discuss today in terms of IP addressing. Because the whole basics of because the whole concept of IP addressing, one of the things that makes it so important is because everything that we'll be doing as network admins or system admins, everything revolves around the IP addresses. So it's something that we must understand clearly and be able to say, well, this packet is generated from here and this packet goes here, and this packet is generated from here and this packet goes here, because it's so embedded in everything that we do. Um, okay, so let's start this way. So we'll talk about IP addressing by first of all talking about the internet. So we all know what the internet is. So the internet is basically just a collection of networks together. So if we go here and go internet, let's see if we can find a good image for the internet. Yeah, this one is a good one. Yeah, here we go. View image. So this is a good image. So the internet is basically a collection of networks that are connected to one another, right? So you go one network
Right.
here, another network here, another network here, another network here, another network here, and they're all connecting to one another. And the whole reason for that is this. So let's think about it this way. Um, so there's a network here. Let's say this is in the UK. Let's say this is in the US. So Sean is over in the US. You have your network there, and we have like all these many networks all over different networks. Yeah, I think we get the point. So they're like different networks everywhere. So these networks, as they stand, they have computers connected to them. So this network has all these computers connected to it. This one over here has all these computers connected to it. This one over here has all these computers connected to it. This one too has all these computers connected to it. Same as this guy over here, he has computers. This one too has computers, and this one too has computers connected to it. And they're all connected together. So they're all connected. This one is connected, and this one is connected, and this guy. So they're all connected, right? And then what we'll have is we'll have
Yeah.
routers between them. Like so that's the way it is in the real world. So we'll have routers between them. So we have, so if I go bring up Cisco routers, just get this one. Yeah, this one. Just copy, just use this one for now. Make him smaller. So we have a Cisco router here. Um, this one's got a router here also. Yeah. So we have all these routers. This one is connected to this router here. This one is connected to this router here. This router is connected to this router here. This one is connected to this router here. And this one is connected to this router here. And this one is connected to this router here. And this router is connected to this router here. And this one is connected to this one. And this one is connected to this one. And this one is connected to this one. So we have all these, devices all around the world. So let's say this one is in Germany, this one is in the UK, this one is in US, this one is in Spain, this one is in Africa, this one is in Australia, all around the world like that. Now, all these networks, they will have addresses. So now we're not talking about these devices now. So we're not talking about the computers, we have addresses. These networks. So we have one network here, right? Oh, sorry.
Yeah.
So Z. So so this is a separate network by itself. This is another separate network by itself. This is another separate network by itself. This is another separate network by itself. Another separate network, another separate network, another separate network. They're all connected together using routers. So all these networks, we have addresses. So let's say this network is 192.168.1.0. That's the address of not the devices on the network, but this network itself. This
Yeah.
one is, let's say, 10.0.0.0. That's the address of that network. So um, the whole point is if this guy over there, okay, so let's say this one is 192.168.3.34.0, the network address of this one. This one is 172.16.5.0. This guy here is 134.0.0.0. Let's not put that. 134.2.0.0. This one is 222.1.1.0. And this one is 123.1.0, sorry, .0.0.0. So we have all these networks with their addresses, not the host on this. So this guy on his network can go and say, well, this machine, your address on this network is .1, So that would be 192.168.1.1. So you can go to say to this one, your address on this network, the second one, is .2. Well, the third one, your address on my network is .3. The fourth one, your address on my network is .4. Let's extend this a bit, is .4. And this other guy too can go on his network and say, yeah, I've got my address is also, so let's say this one is .1. And this other one, I'm going to give you .2. This other one, I'm going to give you .3. So you're on my network. So let's say this .3 over here happens to be BBC's web server. And here is shown with an IP address of 192.168.1.0. Sorry, 1.4. You're over here. So here is Sean here. And Sean wants to access an information on BBC server. So your machine needs to communicate with BBC server, which happens to be on this network here. Now, whenever your machine is packaging a packet, the first thing it will do is, well, I know what my IP address is. Yeah. So I'll put that in the source. And the source, so if I want to communicate with the web server over here, the source that I'm going to is my IP, which is 192.168.1.4. Yeah, it's like, okay, the device that I'm going through is
Yeah.
is 172.16.5.3. Yeah, that's the device I'm going to. So it puts that there also. So it goes, okay, now I have to, before I go to layer 3, I have to go via layer 2, right?
Yep.
So it's like, okay, my own MAC address, my own MAC is, let me see, I think someone just joined. Let me have a quick look at that. Okay, we have Moise. Hello, Moise. So actually, I just joined. So the MAC address, let's say my MAC address here is AAA, and the MAC address of this guy here is BBB. So let's say this machine wants to communicate with another machine on its network. It doesn't need this guy to communicate with it because they are on the same network. So it's just going to go, my layer 2 address is AAA, and I'm going to layer 2 address BBB. And the way it's going to find out is it's going to send a communication called an app out on this network and say, okay, I know this device that I'm going to right here, 192.168.1.3, we're on the same network. I want to send a data to you. I need your layer 2 address. So if I go on my machine now, if I go app./a, you can see my machine, right?
Mm-hmm.
So if I go, let's make it larger. Edit our properties. Let's make it a bit larger font. Yeah. So if I go app.a, so here's my machine, some of the app that it's found out. So my machine wanted to communicate with this device here. So it just, because this device is on the same network that my machine is on, because that's my machine's IP address, my machine just sent a broadcast to everyone on the network and said, hey, I need the layer 2 address of this machine. I know we are on the same network. I know we all belong to 192.168.1 network. I know that. So I need your layer 2 address, please. And when this machine gets it, this dot one will be like, oh, no, that's not my IP address. And it's going to drop that packet. Dot two will get it and say, well, that's not my IP address. I'm going to drop that packet. Dot three will go, well, that's not my IP. Sorry, that's my IP address. Oh, here's my layer 2 address. And it will send it to my machine. Then my machine will craft this packet with layer 2's, sorry, with dot three's MAC address. But if it's going outside its network, so my machine goes, okay, my IP address is 192.168.1.4. I'm going to 172.16. Hold on, that is not my network, right? That is not my network. So which means for me to talk to a machine that is not my network, I have to go talk to my default gateway. Because the machine is not my network, if I send a broadcast, there's no way the machine is going to get that broadcast. So it basically sent an app out, and the app it sends out is, hey, my default gateway, I need your MAC address because I want to send a packet to you. But here's the point. Here's another question that I've got for you, Shane, is this. How will this machine know what its default gateway is? How will it know what its default gateway is?
Through the router.
How? Through the router. How? In what way? The answer is this.
Is Mac.
This is the answer. We tell it. We have to tell the machine this is your default gateway. Otherwise, the machine cannot know what its default gateway is. And there are two ways we can tell it. We can either tell it manually or we can tell it using DHCP. So if I go on my machine now and I go, let me go open network and sharing center, adapter settings. I can go here and go properties. on the properties and go to IP address, and I can go, okay, your IP address is this, your subnet mask is this, your default gateway is this. You get the point? So I
Yeah.
have to tell it its default gateway. I can either tell it this way, or I can go obtain it automatically using DHCP. So in other words, I go to a server and I say to the server, configure this machine to use this default gateway, which is what my machine is using. So if I go IP config now, so my machine has received a default gateway via DHCP server. So if my machine wants to send anything to a machine that is not on its network, the first thing it will do is it will craft a packet going to the destination IP address of that machine, but the layer 2 will be the layer 2 of its default gateway. So when the router gets this, the router gets this one. The router is like, okay, yeah. So the router gets this packet. The router will examine the source IP. Okay, yeah, 192.168.1.4. That's good. Then we examine. Oh, sorry. The router, when it gets this, won't start at layer 3. It will start at layer 2. So it will go to the source MAC address here and it's like, yeah, you're AAA. Yeah, that's good. Oh, I've got an information for me because I'm BBB, right?
Right.
And it's like, oh, I've got an information for me. Yeah, that's good. So it's going to strip away the layer 2. Then it's going to go to the source IP address and like, yeah, so the message is coming from 192.168.1.4. Then when it gets to the destination, it's like, oh, this packet is actually not for me. It's actually going to someone else on another network. So this router will now go, now I have to compose a new layer 2 because basically I've stripped this layer 2 away because I thought it was for me, right? I was thinking, because when I saw the layer 2 says BBB, I was thinking it was for me. But when I got to layer 3 says, well, I'm not for you, I'm just passing it through you. So the router will basically have to compose another layer 2 another layer 2 to that packet and says now the source MAC address will be the router's MAC address, which is BBB in this case, right?
Yeah.
And then, but the router is like, okay, I have no idea where, maybe the router has no idea where 172.16.5.0 network is. But maybe the router has been configured to say, anytime there's a packet that is sent to you that you don't know where the network is, send it to this guy over here. And this guy over here, his own MAC address is CCC, right? So the router will just
Mm-hmm.
compose the same message and says, well, leave the source IP, leave the destination IP, and go, this message is from BBB to CCC. Now, when CCC gets this, CCC is like, yeah, I've got a message that just came in for me. I'm CCC, you know? So it goes, strips that away and goes, yeah, this is going to be a good message. Takes this away. Then it goes to layer 3 and is like, the source is from 192.168.1.4. Yeah, that's good. But the destination, oh, you're not sending it to me. You're actually sending it to another machine on another network. So what will it do? What do you think it will do, Shane?
Forward it to the next router.
So it's going to compose another layer 2, right?
Right.
And now this layer 2, what will it use as the source? What will it use as the
Uh,
source? So let's say the source, so this is the same router, right? Let's say it's been configured. Let's say this router has been configured to say, if you're going to 172.16.5.0 network, we're not talking about device now, network. You're going to this network. The way to get to this network is to send it out this particular interface. And this particular interface has a MAC address of DDD. And this interface over here has a MAC address of EEE. So what will be the source MAC address of this one that this router is now composing?
E.
The source.
Oh.
So it's going from this router now and it's sending it to this router. So
Um.
because the source is this machine, right?
Yeah.
Yeah. So what do you think the source MAC address will be?
DDD.
Yeah, so it's gonna be like, okay, um, DDD, I want to talk to you, EE, right? I'm
Right.
sending a packet to you, EEE. So when EE gets it, what will be the first thing that EE will do?
Um,
It will check the layer 2, right?
right.
And you'll be like, oh, I've got a packet for me. Because it says in layer 2, it says EEE. Then it's going to strip away layer 2. And it's like, yeah, this is for me. Then it goes to layer 3 and it's like, oh, the source is actually 192.168.1.4. And it's not going to talk to me. It's going to talk to 172.16.5.3. But now this one is connected to this one. So it knows that this network 172.16.5 lives on this router over here. So it knows. It knows via something called the routing protocol, which is for another time. But let's say the MAC address of this guy over here is 111, and the MAC address of this one over here is 222. Then let's say the MAC address of this guy over here is 333, and then the MAC address of this guy over here is 444. So can you talk me through what will happen from here? So with your
Um,
understanding of what we've discussed so far, what do you think will happen when it gets to this router here?
um, Going to have an out MAC address.
Yep, MAC address. So what will be the source MAC address?
222.
Ah, again, remember, it's sending from itself. So source is who I'm myself. Destination is who I'm talking to. So what do you think the source will be for the MAC address? Because this one is 111, this one is 222, this one is 333, this one is 444.
111.
Yep, 111. And what will be the destination that is sending to?
Um,
So what do you think the destination will be?
222.
222. Nice, very good. So now this packet has found its way, finally, has found its way over here. So when it gets to this guy over there, what will it do? So this guy has received the packet now. So what will it do?
Send it out 333.
Yeah, good one. So it's going to be like, oh, you're not for me, right? So it's going to go, okay, I have to take care of this guy over here because you're not for me. So again, remember the first thing that you do is that it will look at layer 2 and then strip it off because it thinks it's for me. So it's like, you get a letter, you open it up because you think it's for you. So think of it like someone wants to send a letter to your friend that lives in, or someone, let's think about it this way. And where do you live again? You live in Indiana, right?
Right.
Yeah. So Indiana is the city. So what's the state of
Um,
of Indiana?
it's Indiana, USA.
Indiana, USA. So that's the state. So which city are you in Indiana, or which area are you in Indiana?
Oh, Carmel.
Yeah, Camel. So let's say it this way. So someone is sending a letter from Oxford in the UK to your address. So on the letter, it's gonna say, well, I'm sending this letter to Indiana, right? So the
Right.
guys in Indiana post office gets the letter. They're like, oh, you're sending it to Indiana, but you're just sending it through us. So it's actually going to Kama in Indiana. So then they transfer your letter to Kama in Indiana. Kama in Indiana will go, oh, you're sending this letter to us. It's got our name on it, but it's not actually going to us. It's just going through us to go to this street address. So then it goes all the way to your street. So then your street gets it, and your street is like, oh, you're sending this thing. Although it's got my name on it, it's not for me. You're actually sending it to this house number. You get the point? So
Yeah.
it's the same way. So this one goes, okay, you're just going through me. You're not actually sending anything to me. So it creates a new layer 2. And the new layer 2, the source will be what?
333.
Exactly, very good. 333. And then what will be the destination?
444.
Exactly. Very, very good. So it goes destination 444. So now this packet has traveled all the way and it's finally arrived on this network. So when it arrives on this network, when this switch receives it, this switch goes, oh, it goes, okay, yeah, I've got something for me on this port because my MAC address is 444. So it strips away layer 2. It's like, yeah, this message is for me. It's a good message, goes away. But then it's like, oh, maybe this IP address is 192.168, maybe 5.1. It's like, oh, you're not actually for me, but you're sending a message to 5.3, right?
Right.
So it's going to go, but hold on, that is on my network. So what it's going to do is the same thing this guy did here. It will do an hop. So it's going to do an hop to say, all the guys on the network, I've got a message for 172.168.5.3. If you're 172.168.5.3, can you send me your MAC address? Again, remember hop, right? So this
Right.
dynamic means my message has sent a message to everyone on the network, and then it's going to reply from this machine saying, this is my MAC address. So when this machine gets that hop message, this machine will go, wow, I've got I've got someone asking for my MAC address here. Then it's going to reply and say to this guy, this is my MAC address. Then this guy will craft the final packet, which will now say, well, the source MAC address that we are coming from, in this case, will be probably 444. Then maybe this one's MAC address is 555. And then I say, I'm going to 555. Now, when 555 receives it, 555 goes, yeah, I've got a message that just came in for me. I'll strip this one away. And then when it gets to it, it's like, hold on, this is this guy on this other network sending a message to me on my network. So it's going to take that message and strip this one off. And behind this, you have your data, right?
Right.
So you have your data here. So it's going to strip off the layer 3, and then it's going to read the data. And then it's going to reply, and then we go through the whole process again. So you get the point, right?
Yeah.
Yeah. So so that's actually what's going on, like on network communications. Every time you're trying to communicate with something that's not within your network. If it's within your network, it's a different issue. Your network just sends an app, your machine just sends an app and finds out the MAC address and just direct it directly to that MAC address. Okay. So here's a question, because we're discussing IP addressing today. Is that um how do this IP addresses and everything, how do they come by? And I mean, how did we even start with like the whole concept of IP addresses and all that? So the whole thing was that like in the beginning, we had networks like this. We had
Hmm.
um, the guys in the universities in US decided, yeah, I think it's time for us to have a way for us to communicate with each other electronically, and they decided to start connecting networks with one another. So in the beginning, they decided we're going to come up. So let me move this one to the side. We'll come back to it. We're going to come up because if we're going to be communicating with each other, there must be a way to identify which network this one is on and which device it is, right? Because if this
Right.
guy wants to communicate with this guy, first we must find a way to identify this network, and then we must find a way to identify that device on the network. So they decided what we're going to do is we're going to have something. And tell me how how they came about that name. I'm not sure how they came about the name, but they decided we're going to have something called an IP address. And then they decided that, okay, this IP address will be a way for us to identify networks and devices that will be connected to this network that we are going to be a part of. So they decided that there will be a network part in this IP address, and there will be a host part in this IP address. Just as in the case that we looked at just now, there's a network part, you know, the 192.168.1, right? And then there's a host part,
Right.
which is the last octet, right? So they decided, oh, we're going to have this network part and we're going to have this host part. And then they decided, I'm not sure why they decided that way, it could be something random, but they decided that this IP address will be a 32-bit address. And they decided that this 32-bit address, what will be 8 bits in 4 parts. So what that means is that you have 32 bits, right? But what you do is you
Mm-hmm.
have 8 bit here dot 8 bit here dot 8 bit here dot 8 bit here. So they decided that that's the way this address will function. So we'll have a 32-bit address with 8 bits in 4 parts. So actually, the 8 bits just stands for an octet. So when they say an octet, so what they mean is that we'll have 4 octets. So they decided that, and then they decided that we'll have a way of finding out what the network part is and what the host part is. So in the beginning, really smart guys got together and decided that. So then the thing they came up with was this. They were like, okay, there are 3 different types of network in the world, or 3 different kinds of network in the world. The first kind are very large networks. And then there's like, well, we also have medium sized networks. And then we have small networks. So they're like, this is what we'll do. We'll have something where um, we'll have an address for large networks, or we have an address space for large networks. We'll have an address space for medium networks. We'll have an address space for small networks. So when you're talking about 8-bit, you're talking about um, a situation where you have 8 bits. 8-bit simply means it can be a 1 or a 0. So you have 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8, making 32 bits. And each one of these bits represent the value from 1 to 8, 64, 32, 16, 8, 4, 2, 1. So if you want to count it, just start at 1 and start counting and start timesing by 2. So 1 times 2 equals to 2, 2 times 2 equals to 4, 4 times 2 equals to 8. So they decided that this is what we're going to have. So we're going to have, this 32-bit address, 8 bits, just 4 octets with 8 bits each in 8 octets. And the values will be 1, 2, 4, 6. It's easy to go 1, 2, 4, 6. It's 1, 2, 4, 8, 16, 32, 64, 1 to 8. So what that means is that you can go, because there are 8 bits in each octet, that means each octet can have a maximum of 256 combinations. And the way to find that out is if you just bring a calculator and go to exponential 8, you get 256. So you can only have a maximum of 256 combination if you have 8 bits. So that means we have a value between 0 and 255 for each octet. So now, when they started, so what we were like, okay, very large networks, what we'll do is the way we'll identify you is if your first octet is between 1 and 127. That's the way we identify you. And the other thing we'll do is that the first octet will be for the network, and the last 3 octets will be for the host. Oh, sorry, that's a mistake. 1 to 126, we'll get to that. So that, okay, for very large networks, what we'll have is the first octet will give them numbers 1 to 126, where the first octet will be for the network and the last 3 octets will be for the host. So what that means is that in this first octet, we can have, so they decided we can have 126 very large networks, right?
Right.
And then we can have, so if you go, you know, the remaining bits that we have left is 8 plus 8 plus 8. So that's 24. So if you go 2 exponential 24, 2 exponential 24, that is 16,777,000. So not many networks will have this amount of devices on them. So they're like, yeah, so this network that we'll have just 126 of them. Each of this network can have 16,777,216 devices on them. So let's see. So big guy, little guy. I got this image. So let's go copy image. Then yeah, see where I'm going with this one. And this other guy, let's just put him to one side. Yeah. So this guy comes, he's a really big guy, right? So he comes to
Mm-hmm.
the guys that controls the internet and he's like, yeah, I heard that you guys are doing this thing called, network where we can all come together and share information with one another. I'm a really big guy. I've got lots of devices, that are connecting to me. I need a network address. So they'll go, well, you're a very large guy with very large network. So we'll give you, you know, 1.0.0.0. And this address belongs to you. So you can do as you want with this address on your network because you're a really big guy. So you get this address on your network. So another big guy goes to them. They give him maybe 2.0.0.0. And what that means is that you can have 16 million devices on your network. So you can go and go, okay, now they've given me an address for my network. Now the first device I'll put on this network, I'll have 1.0.0.1. The next device I'll put on my network, I'll have 1.0.0.2. The next device I'll have on my network, I'll call it 1.0.0.3. So I can just go ahead and give devices on my network, you know, this address is up to 16,777,000. So they will go up to 1.0.0.255, right?
Uh-huh.
Then it will go and say, well, I can do anything I want with this last 3 octets. The only thing I can't change is the first octet because these people have decided the first octet is for the network. So we're giving you a network address, not a host address. Host address, you decide. But the network address, you cannot change it because that's what we're giving to you. So they've given you class A network address 1. You can do anything you want with the part with the last 3 octets that belongs to the host, but the network address you can't change. So when you get to 255 here, you're like, yeah, I'll just go 1.1.0.0, and just carry on that way. Now, the only exception is that there are 2 addresses that have to be reserved on this network. The very first address that this network has, you have to reserve it for the network. And the very last address that this network has, you have to reserve it for a special address called a broadcast address. So what that means is this. So you go 1.0.0.0, you keep counting it this way. So eventually you get to 1.255, right? Dot 255 dot 255 because 255 is the maximum you can get to for any octet. So when you get to that maximum, so that's the last address on this network. So this is the very first address, right? This is the
Mm-hmm.
very last address. The very last address, you can't give it to a device because you have to reserve it for something called a broadcast address. So this address will be your broadcast address. And this is what a broadcast address is for. A broadcast address simply means, so let's say this guy has got 10 here. If this device over here wants to send a communication to every other device on this network. There's a special address that you can use. So if you send anything to that address, the communication will go to this guy, it will go to this guy, it will go to everybody on this network. And that address has to be reserved. That address is called the broadcast address. So again, remember the very first address for any network, you can't use it because otherwise, how will this guy know the network that is supposed to communicate to? So the network itself has to have an address because this is really important also. Because the routers, you see the routers, right?
Mm-hmm.
Routers don't really deal with devices, they deal with networks. If you go on a router and you go to do something like show IP route, what you find are not, device A, device B. What you find are networks. What you find are the router saying things like, if I want to get to network 222.1.1.0, I'll send it out of interface fast01. If I want to get to network 134.2.0.0, I'll send it to this guy here, um, which is outside interface fast02. You get the point? So routers
Yeah.
don't really deal with hosts, they deal with networks. So the network has to have an address. So if you want to go from this one to this one, you first have to address it to this network. So it gets to this network first, then we're going to determine where the device is on the network. So the very first address on any network that these guys that created the internet that they give to you, you can't use it. So that address will specify what your network is. And the very last address on the network space that they've given to you, you can't use it either because that has to be reserved for the broadcast. So if any device wants to send a communication to everyone on this network, it will go to this address. So that's for the big guy. Then we have like the much smaller guy, which is like not as big as this guy. So this one goes to the guys that created the internet and is like, well, I also need an IP address. I'm not as strong as this guy, but I also need an IP address for what I'm doing. So he goes and says, well, I need an IP address. So these guys will go, okay, you the medium-sized guys. What we've done for you is your first octet will start from 128 and it will end in 191. And what we'll do for you is that the first octet, the first two octets will be for the network, while the last two octets will be for the host. So what they've decided to do is like, okay, so you go, so this guy can have 128.0.0.0, yeah?
Yeah.
So 128.0 is reserved for the network. So you can't do anything with it. This other part belongs, you can give it to any device that you want on your network. So another guy goes to them and goes, hey, I want an IP address. They can go 128.1.0.0. So just remember, the first always starts with this number that they've designated, right? The first octet always starts with this number. And the parts that they've reserved for the network, you can do anything with it. So this guy goes to them and says, well, I also need the network. I want to join this thing called the internet that you're doing. So they're like, okay, your IP address is 190.2.0.0. So what that means is this first octet is your network part. You can't change it. You can't touch it at all. Because if you go, okay, I'll change it, I'll go .3, that belongs to someone else, you know? So you can't change it. That belongs to someone else. So you can only stay with the one that they've given to you. But these other ones, you can do as you want with it. So this other one will give you, I think, a combination of 65, 534 addresses. So again, the same rule applies. The first address on that network, you can't use it. So this is your network address. And then when you go to start giving your devices on the network, so you go 190.2 192.0.1, you give that to your first address, to your first device. You go 192.2.0.2, you give that to your second address. You go all the way to 192.0.255. And like, oh, then that's finished for that octet. So you go all over again and go 192.1, sorry, .2.1.0. So that's another device. So you go 192.1, sorry, .2.1.2. So you keep going that way till you get to 192.2.1.255, and then you finish that octet. And then you go again, you go 192.2.2.0. You get the point. So you
Mm-hmm.
keep going that way. So that's for you. You can do as much as you want with these last two octets, but this first two, you can do anything. So you can have a maximum of, this one can have 60 million devices on its network. You can only have 65,534 devices on your network. And remember, the very first address, you have to leave it alone for the network. And the very last address, you have to leave it alone for the broadcast. Okay, so now, then the little guy also is like, yeah, I know I'm not as big as these other guys, but I also want to join this thing called the network that you have. So goes to talk to them, and they're like, I also need a network. And they're like, okay, what we've done is for you small guys who have um, small businesses, organizations, what we'll do for you is your very first octet is between 192 and 223. And what we'll do is the first three octets will be your network. Why the last, last octet will be the host. So 192.223. So that means they can give you 192.1.1.0. This three, you can't touch it. The only one that you can touch is this last one, because if you go and change this one and you go .2, that belongs to someone else. So you go .1. So this belongs to you. This is your network address. This particular part that belongs to the host, you can do anything you want with it. You can give it, to any device on your network. So you can go, well, I can't touch the first address. That belongs to my network. So you can go, on my network, I have 192.168, sorry, .1.1.1, and you can go 192.1.1.2. Then when you get up to 192.168.1.254, and then 192.1 sorry, not 168 dot 1.1.255. This address, can you use it for a device on your network?
Um, yeah.
Why? Why can you use it? Because that's the last address on the network that they've given you. Because you can only go between 0 and 255 for every octet. And this is the last address for this particular network that they've given to you. So you can't use it, right?
Okay.
Why can't you use it?
Because the broadcast.
Yeah, because it's reserved for the broadcast address. So if this device wants to communicate with every other device on this network, they are all listening to 192.1.1.255. So anything is sent to this address, everyone on this network will get it. So that's the way they started with to begin with. I mean, they had everything. They were like, we can have 126 very large networks, yeah, and each of them will have 60 million devices. And this one, because we are using the first two octets for, because we're using the first two octets for the network part, and using the last two octets for the host part, what that means is this. What that means is that we can have a total of 16,000, about 16,384 networks, and then we can have each one of them will have 65,000 can have 65,534 devices on them. So you in the real world, what you find is you find like all these different networks. So this network belongs to like the little guy, he can only have 254 devices on the address they've given to him. This one belongs to a really huge corporation. They can have up to 64 million devices on that. This one maybe has can only have up to 65,000 devices on him. So you have all these different networks. So very soon they ran into a problem. I mean, the smart guys that that thought of this one, they ran into a problem very soon. And the problem they ran into was that what began to spread that there's this amazing thing called the internet where every one of us can join together and we can communicate with one another and share information with one another and everybody were registering for the internet. So every corporation, the big guy, the little guy, the medium guys were running to them and they were like, we need addresses. And they're like, if we keep going this way, we'll run out of addresses very soon. Because we thought, we have 32 bits. 2 exponential 32 is 2 exponential 32 is 4 billion. So they were like, wow, there's no way we're going to exhaust that. 4 billion devices on this big network. 4 billion devices. But they underestimated what was going to happen. Because very soon everyone was registering for the internet, everyone wanted their own address, everyone wanted to be part of the internet. And we were running out of addresses, and they were like, okay, let's have another meeting, guys. So they came together again, the intelligent guys, and they decided what we're going to do now is with this problem that we're having with everyone running out of addresses. So their response was something called RFC 1918. So that was their response. So RFC 1918 that they responded with was basically them saying, so if I go, let's maximize this. So look at this. So this was in 1996. Look at the motivation. It says, with the proliferation of TCP/IP technology worldwide, including outside the internet itself, an increasing number of non-connected enterprises use this technology and its addressing capabilities for sole enterprise communications. And then look at this. It said, the internet has grown beyond anyone's expectations. So they were like, hey, guys, let's have another meeting. This thing is going beyond what we expected. We were thinking 4 billion devices. There's no way we're going to be close to that. And they were like, hold on. This thing is going beyond what we expect. Sustained exponential growth continues to introduce new challenges. So one challenge is a concern within the community that globally unique address space will be exhausted. So they're like, if we keep going this way, we'll run out of addresses very quickly. So they're like, okay, how are we going to solve this problem? This is the first problem we're facing. We're facing a really huge problem. We have to find a solution to it. How are we going to solve it? Their solution was this, something called private addresses. That was their solution. So their solution was that, okay, for every class of network, like the class A network, which is for very large organizations, right?
Mm-hmm.
What we'll do is let's reserve an address space. So that was their solution. Their solution was like, okay, let's reserve an address space for every class and say that address space is private. In other words, you can't use it to communicate with anyone on the internet, but you can use it internally, and that would save us a lot of address. This solution that they came up with is one of the reasons why we still have IP version 4 addresses today. Because if not for this solution, we'll have run out of addresses like years ago. So basically what they meant was this. So we'll have all these things that they call private addresses. So in other words, let's say this guy will like, so the private addresses that they came up with were like, okay, for very large organizations, um, you guys use 1 to 6, right? So they're like
Mm-hmm.
10.0.0.0 to 10.255.255.255. You can use it for anything you want internally inside your network. No one will disturb you. No one will say anything about it. But if you want to talk to anyone on the outside, then you have to use one of the addresses that we are going to be giving to you. So then they said, okay, for the Class B guys, or like the medium-sized organizations, they were like, okay, we're going to say 172.16.0.0 to 172.32.2. So I mean, you don't have to think about, how did they come up with this? All you need to know is that this is what they decided years ago. They were like, okay, 172.16.0.0 then 172.32. Oh, not 32, sorry, not 31.255.255. That one is the private address space for the Class B guys. Now, for the Class C guys, which are like these small organizations, they were like, okay, we're going to say 192.168.0.0 to 192.168.255.255 are your own private address space. So what that means is this guy over here can use, if it's a really large guy, it can use 10.1, or sorry, 10.0.0.0 on his network as his address. Yeah. This guy over
Mm-hmm.
there can also use 10.0.0.0. This guy over here, if he's also a really large guy, can decide to use 10.0.0.0, within his network. So all his devices on this network can use 10.0.0.0. But what will happen is if he wants to talk to the outside guy, they will give him an address. So maybe they will give him 11.1.1.1, just as an illustration. Yeah. So let's say they give
Right.
him 11.1.1.1. So that means there must be a new technology that must be able to translate addresses that is coming from inside to addresses that is going on the outside. So that new technology we'll be discussing it down the line, is a technology called NAT, or Network Address Translation. And what NAT does is translate private addresses to public addresses. So actually, you can't route, see these addresses here, all these addresses here, you can't route them on the internet. So you can't ever find um, um, a packet on the internet, on the ISP's network, with a source IP of 10.0.0.1 because they've been marked as private IP addresses. In other words, you can't go on the internet. You can use this in your private network, right? But if you want to go out
Mm-hmm.
on the internet, it has to be translated to the other addresses, which are public addresses. And this has saved a lot of spaces because now everyone don't need to have unique addresses. So they can give this guy just one address, and then this guy can have as much devices on his network and use any of the private address space. But when it's going on the outside, all he needs to do is configure his router to translate the internal IP to the external IP. And that's the thing we use at home, and in our networks today. So maybe in my place or in my house, we've got a ISP. They will give us maybe just one IP address. But inside, we have like maybe about 15 devices. All those devices are using one of these private network addresses. Yeah. But then when they want to go outside, the addresses will now be translated to the address that the ISP is giving them. So that's like, so they were like, yeah, we solved this problem already. So that's a really good one. We found the solution to this problem. Private IP address is the solution. But then very soon another problem came. And the other problem was that, think of this guy, for example, this guy that is a very large organization, right? So
Mm-hmm.
they've given him an address of 10.0.0.0. What that means is it can have over 16 million devices on his network, right? But the problem is this. As this guy's network kept growing, so this guy has a switch, he has a switch on his network, and let's just copy this. And let's just go, yeah. So this guy, let's drag that down, drag that down. So this guy has his own network, right? Has he kept adding devices to this network? So he's adding devices and adding devices and adding devices every time and connecting them to this network. What he started noticing was that, hold on, my network is slowing down. And the reason is because this device decides, oh, I want to send the communication to everyone on this network. Which computers do? They send broadcast, right? I mean,
Mm-hmm.
the computers have to send broadcast at some point. For example, my computer wants to communicate with another device. It's like, I don't have the MAC address of this device. So what will it do? It will send a broadcast. A computer comes on the network. It's like, I don't have an IP address. I need a DHCP server that can give me an IP address. It sends a broadcast. So these computers are constantly sending broadcasts. And the thing is that this broadcast now, maybe they start from 10 devices. Now they've gone to 1,000 devices. Now they're going to 20,000 devices. And what that means is that 20,000 devices are sending net broadcasts. So think of what that would do to these switches. So this guy sends a communication and is going out. So this communication that this guy is sending out is going to everyone on the network. Every single one on the network is receiving it. So it's going to this guy, 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 to this guy. And this is being sent by 20,000 devices. So this guy is constantly busy sending out broadcast everywhere. That will crash any network. So they're like, this network is getting slower because actually it's not feasible to have a network this large with 60 million devices. So they were like, hold on, guys, we have another problem on our hand. What do we do with this thing that keeps going larger and larger and larger? And, it keeps going larger and larger and larger. And there's no way we can sustain this because of too many broadcasts. And their solution to that is subnetting. Subnetting, simply put, is a process of breaking down a really large network into smaller networks. So that's the process. So that's what it's called. So now this guy's got breaking. So let's say this guy's got all these devices, right? So what this guy can do is go, okay, I've got this address space of 10.0.0.0. What I can do is I can have a switch here and have another switch here on my network and have another switch here. And then between these switches, I'll have a router. So let's just use a circle for a router. I have a router. So I'll say devices, that are connected to this one. Let's go consider. So devices that are connected to this switch here, they've given me 10.0.0.0, right? So now the devices that are connected to this one, you're just on 10.1.1.1 network. So which means I can give this one dot one, dot two, dot three. So which means in other words, there are only 254 devices on this network, right?
Mm-hmm.
So you can go the same way and go, well, this other switch. So if this guy wants to communicate with another guy, he has to go to a router because now he's communicating with another network, even though they are within the same network. And what that has done is that it has reduced broadcasts. So now this guy can communicate. If he wants to send a broadcast, it only has to go to 54 devices, right? If this guy wants to send a broadcast, it only has to go to 54 devices. So subnetting simply means you're taking an address space that you've been given and you're breaking it down into smaller networks. And the way you do that is you borrow from the host part and you use it for the network part. So in other words, you're like, yeah, I've gone to the guys that control the internet. They've given me an address space of 19.0.0.0. But what I actually want is there's no way I can put all my devices on this network. That would be too much of broadcast for 19 million devices. So what I can do is break this thing down and say, okay, I want 255 networks. So what I do is I borrow this part, that belongs to the host and use it for the network. And say, well, this network is 19.1 and this other part I'll use it for the host. So that's what subnetting is. Simply means you're taking the part of the host and you're using it for the network to break down a really large network to a really small network. So that's the whole point behind subnetting. Now I know we're not able to go into like details of we're not going to we're not able to go into details of how to actually subnet, but I think that helps you with like your philosophy to know the reasoning behind subnetting.
Yeah.
Yeah. So once you understand, well, that's the reason why we are subnetting today. So because you don't want to have really large networks, because you have really large networks, so really large networks equals to really slow networks. And that's because of broadcasts. So now you have to break down really large networks and make them into smaller networks so that you don't have too many broadcasts in any segment. So that's the whole point. So what we'll be doing is subnetting is to basically say, uh, okay, Shane, I'll give you an IP and say the address is 192.168. You know, 5.0, and I say to you, what I want is I want 5 networks from this address, and I want each network to be able to have, let's say, 20 addresses, at least 20 addresses. You get the point? So now you now have to take from the
Yeah.
host part and break it down to network. And then go, okay, 192.168.5.0. Now, how many bits do I need to make 20 addresses? So how many bits do you need? Just count on your finger. You go 2, 4, 8, 16, 32. So that's 5 bits. So that means in this last octet, you have to use 5 bits. So it's got x 2 3 4 5 6 7 8. So you have to use 5 bits for the host, and the other 3 bits you have to use for the network. You get the point? So that's the whole point. So you have to say, okay, this 3 bit I'm
Yeah.
going to use for the network. This 3 bit I'm going to use for the host. So now you're now calculating the values of this 3 bits and then the values of this 3 bits. Oh, sorry, of this 5 bits. So yeah, I hope that will help you in your studies and all that. So that's just a quick breakdown of of just a brief history lesson. How did we come to get to subnetting to begin with, and what's the point behind subnetting? So I think that's where we'll stop for today.
Okay.
Yeah, yeah, okay, no problems, man. So I think we'll set up Hangout again for next week and all that. So yeah, so just look out in the group and all that. And I think we'll put recordings of this also out on the group. Okay, yeah. So see you later, Shin.
That is really great.
Yeah, no problems, man. Yeah. So yeah. So again, we'll just carry on studying until we get to CCNA and all that. So see you later. Have a nice evening or morning. Yeah, bye for now.
I'll see you. Thank you.
No problems, man. See you later. Bye.